Good morning, guys. Good morning for the guys in India, and good evening for the guys in the United States. As Ravi was introducing me, I'm Kumar here, and I have about 13 years of experience, and quite a lot of that, almost close to 6 years of that, I have been spending that as an architect in various capacities, infrastructure architect, cloud architect, and solution architect for multinational companies and solutioning for clients usually based in US and UK. That's about me. I'm not going to spend much more time talking about myself. I know you are here to understand or to make a decision of why I need to go with AWS or why I need to go with DevOps, or do I need them, both of them, or should one is enough? So to help you guide your decision, I'm going to take you through some of the aspects of what is cloud computing, what is AWS, what DevOps does, and I'm hopeful that by the end of this session, you should be able to make a decision and choose which technology is right for you. And I hope that I can clarify all your doubts at the end of the session if you have any. So without wasting any more time, let us get into the session. So that's about me. So briefly, we will be talking about, or we will be seeing what is cloud computing and why we are talking about AWS in particular in cloud computing, and what makes AWS work, and what we cover in our sessions and trainings in AWS. And again, why DevOps, what is the thing wrong with existing networks or existing technologies, and what we cover in DevOps, and what are the next course of actions that you can take. That is what briefly we are going to see today. So starting with why cloud computing, what is wrong with the existing business models, what is wrong with the existing traditional networks. Before I can go ahead, I can spend about at least 5 minutes to understand some of your experience and technical skills, so we know that we have a good mix of crowd. Can anybody volunteer to give up their name and their experience and what is their core skill?
Yeah, I have muted everyone, so you can unmute and you can talk about this. Or else you can ping me in a chat also, not a problem.
Okay, fine. In that case, okay, what I was expecting is just trying to understand who, who are having a technology-based experience in the background. Like for example, some people might be a Linux admin, some people might be a storage person, or somebody might be an application hands-on person. Somebody might be a core developer or a scripting person, PLSQL. It could be, or Python. I'm just trying to understand what makes you think. What do you think of cloud computing when somebody says, "Do you know about it?" That's all I was trying to understand. It's no worries. I'll just dive in to see where we are and where we need to go. I have a rough comparison of what is the traditional infrastructure on the left-hand side and the cloud services on the right-hand side. You can ignore the right-hand side as of now and focus your attention on the left-hand side. Usually you see on-premises you have direct attached storage, SAN, and then some servers, and then you have network teams doing networks, and then security is provided by firewall guys, system administrators, and then you have a lot of people like that. So what is wrong with this model is when you want to grow from, say, for example, 100 users to 100,000 users, then you need to carefully measure your demand and you need to carefully measure your capacity and monitor and track the progress of your growth and estimate how much capacity you will need when you go to 10,000 users or 100,000 users. Say, for example, today you are running a 4 CPU, 8 GB RAM server for 100 users, then would you scale horizontally, like into into 100,000 times for 100,000 users? Or how do you buy capacity and provision it in your data center? That means there's a lot of thinking going into the IT manager's head to think about the capacity they need for future growth and how to optimally use that capacity, because you are investing so much of money into the infrastructure. and all that infrastructure is going to sit idle if you are not going to use it until the peak capacity comes in. Some of us might be aware that Christmas is a quite an important business season for the American clients. We usually have a change freeze or some kind of a freeze to make sure nothing goes wrong in the server and meet the peak capacity. Whereas in India, somewhere like October, November, the Dashara or Diwali is the peak sales season for online web players. So for meeting that capacity, a lot of effort goes in, and you build like something like 100 CPUs or 1 terabyte of RAM. But what happens to the rest of the month? It is all sitting idle. You are not using that capacity. So in traditional infrastructure, the problem is you build your infrastructure for meeting the peak demand, and you spend a lot of money, that let us call it a capital expenditure, capex. You spend a lot of capex and you provision those servers and wait for somebody to use that. And 8 months you're not using it, and you're using only for 2 months, and then the rest of the time it is sitting idle. But you still need to do the security part of the infrastructure. You need to do the networking. You have to make sure the cable is working. You have to make sure the storage is working. Make sure the disks are not failing all the time, and make sure the application new features are launched all the time. So while you're doing this maintaining work, still your infrastructure is sitting there without doing any business. So that is one of the critical problems of cloud, traditional infrastructure. When you compare that to cloud, some of those problems goes away magically. I'll tell you why and how. Before going that, let us look at what exactly the models that we are talking about here. Before we move that, yeah, let us look at the models that we are talking about when you talk about cloud computing. There are different types of cloud computing models that you see when you're talking the enterprise stack that is on the left hand side, where you manage everything. That is, as you can see in the left hand side, it is all customer managed, from your data centers, from your networks, from your servers, virtualization, all the way up to application. But when you move the virtualization stack and below that everything to a third party, that is a provider managed, it might be your a cloud service provider, or it might be your co-hosting service provider. There are so many business models are there available in cloud computing. So when you do virtualization to data center and the customer is managing the operating systems, let us see if I can use my marker and show it. So this part I'm talking about, is that appearing there? Yeah. So if you are able to manage only this part and give up the remaining bottom part to your cloud service provider or anybody, then we call it, we are talking about an infrastructure as a service cloud model. But if you're leaving everything up to the security of your database, security of your operating systems and everything, and managing only your application might be just in Java code, or your application might be a Python or anything, then we are talking about a platform as a service model. Quite a lot of cloud service providers like Amazon, Azure, and Google fall into this model, platform as a service. And there is a final one service called software as a service. If I have to take an example, one second guys. Considering if I have to take an example, quite a lot of us have used Gmail or Facebook or some kind of service like that, which perfectly followed an example of software as a service. You might also remember some of us use Microsoft Outlook or Skype in our enterprise, where Microsoft installs it, configures it, maintains it, and does everything for the infrastructure and make sure everything is accessible and available. That also falls into the software as a service model. So these are the very broad-based cloud computing models that is available in the market, that is infrastructure, platform, and software as a service. And 90% of the cloud services that enterprises are consuming are in the platform as a service model. So how do I consume these things? How do I integrate it with my on-premise model? So you have three different options for that when you are talking about integrating with my on-premise model. That is a private cloud. That is a very conventional way of doing it. That is, your data center is managed by you. You own everything. That is your private cloud. Everything is internal. You have full control over it. On the other extreme end, you have the public cloud, that is the platform as a service that we talked about. Everything regarding the hardware, regarding some of the software is managed by your cloud service provider. So we call that as the public cloud. So you have two options now, completely private or completely public. So some guys, some enterprises say that, no, I cannot put everything in my public. I want to still keep something in my private also. So that is when you combine both these things and create something called a hybrid cloud. So some workloads, like for example, your finance or HR related data will be on your private cloud, whereas your product brochures or your case studies or some data that you want to share with the public, which is already in the public domain, you want to put it in the public cloud, thereby reducing your resources on premises. So you do a bit of sharing your workloads between on-premises to your cloud. So that is when you go to your hybrid cloud business models. So I kept on talking about cloud computing, cloud computing. What is the industry defines as a cloud computing? Let us look at that. What is exactly cloud computing? Gartner, one of the foremost researching or analyst group that is in the market, says cloud computing is nothing but resources which are massively scalable and they have capabilities that are provided across the internet and to multiple customers. Basically, the way I see it is your cloud has to be massively scalable and the services should be accessible across the internet, and you should be able to share the cost with multiple customers which you are not familiar with. You can be your neighbor, it can be somebody across the planet. That is how Gartner sees cloud computing. How about Forrester? Forrester is another analyst group. They also say cloud should be highly scalable and you should pay only for what you're using, that is build by consumption. What do I mean by build by consumption? What do you mean by massively scalable? Let us look into that now. We all must be very, very familiar with this concept. We use electricity power every day, but we only pay for what we are using. If you remember, there is a meter, whether you're in the United States or in India, electricity is charged by a meter just like any other service, but you only pay for what you're using and your slab increases as much as you increase your consumption. So as long as you're at the bottom of the slab, you pay a lesser number of lesser amount of money for the service that you use, and you start consuming more and more, you fall into a different group of category, and you probably pay more or less depending upon your contract with your service provider. Comparing this with the cloud, it's the same analogy there. So you buy 2 CPU, 4 GB RAM, you pay a certain amount of money for that. You buy 4 CPU and 8 GB of RAM, you pay a different amount of money, and you shut down your machine, you don't pay anything. The machine is still available for you. Let us say, instead of shutdown, let us say I'm stopping the machine, the resources and configurations, everything is available. So you think of it as a car, I have parked in my garage, so I pay for the rental of the garage and I'm not paying anything for driving it around. So that is how cloud is also. You provision a resource, you use the resource, you pay for that resource. You stop it, you don't pay anything. And if you want to start 10 servers, then you will be charged for 10 servers. You start 100, you will be charged for 100. And suddenly you stop 100 to 0, you are billed for nothing. So that is what it means, pay for the services as you go. And there are, one second guys, looks like I messed up 2 slides, so I'm just going to show you that there is another 2 features of cloud. If you remember, massively scalable, we talked about in Gartner and Forrester research. So those are the 2 things that I'm going to talk about next. Any cloud services should be quickly scalable and flexible for business needs. Remember, when I'm talking about the pay-as-you-go, I talked about moving from 10 servers to 100 servers. So that is what I mean by scaling. That is what I mean by elasticity. So from 10 to 100, it should go gradually and as fast as possible. I don't want 100 days to grow from 10 to 100. I want it to happen today. I want to happen immediately. That is how businesses grow sometimes. So cloud services should be like that. I should be able to grow to any reasonable amount of capacity as fast as possible. And most of the cloud service providers, including Amazon, provide you that flexibility with a few clicks of a button, or if you're good with Python coding, you can write a Boto script or auto cloud formation to set it up. So there is one more feature of cloud services that we need to look at. That is resource pooling. What it means is now you are talking about starting tens and hundreds of servers. How do I optimize the cost? So the one of the best way to do is you optimize your infrastructure with, you share the infrastructure with a lot of other customers in a very secure way. Because think of it, if you are doing a carpooling, we are familiar with the concept of carpooling. If you go all alone, you pay a little higher premium for that. But if you're doing carpooling, the cost is comparatively lesser than going all it alone. That is the way here also it works. You share the infrastructure capacities, you share the storage capacities with a lot of other people with necessary security controls in place, then your cost comes down. That is how cloud computing also works. And I keep on talking about security. That is why you will see the lock also, because when you're sharing something with another company or another customer, you are conscious about what happens to my data. Is my data vulnerable? Am I sharing my data with another company which I don't know about? Those kind of questions comes in. AWS gives you robust controls to secure your data when you are sharing it with other customers. They have at least 3 to 4 different services which directly attacks the security controls, and you can tighten it to an extent that even in your company you can restrict access to a certain group of individuals. That is the kind of a security AWS provides you. So why AWS? I keep on talking about other service providers also. So who are all the other service providers and why we need to focus only on AWS itself? And Amazon, we all know, are quite often used as a shopping website. Why should I use a shopping website's computing capacities? Do they have the capability comparable to somebody like an IBM or Microsoft? Why is that? I'm still talking about AWS. Let us look into that. Why? Just one moment. I'm just getting a sip of water so I can continue the conversation. Okay. So I guess meanwhile you had a time to have a good look at what is there in the slide. What I've presented here is the magic quadrant that Gartner usually does after analyzing a lot of players in the area. I'm showing the Gartner magic quadrant for infrastructure as a service through cloud for the year 2016. For 2017, we are just 4 months old in 2017, so the report has not come, but I would not be surprised to see my favorite service provider here at the top. You can see Amazon Cloud right at the top bottom, top corner. You can see it is labeled as leaders, and if you can see at the bottom, it is labeled as visionaries. So that is the quadrant Amazon is, and you can also see there is only one service provider in that quadrant, and that service provider is also a little distance away from Amazon. What it means, what is that dot in the right corner means, why should I bother about it, you can ask me. Let me explain to you that why. What it means is that is Amazon is the leader, and the services and the vision that they have for the services is unmatched by anybody else in the quadrant. The nearest player who is challenging Amazon here is Microsoft, and from what I have read, Microsoft's strength comes from only 3 service products, that is Microsoft Outlook, Microsoft Skype, and SharePoint. These are the only services Microsoft is selling aggressively as an Azure cloud, and a lot of clients who are buying a Microsoft Outlook license is also counted as a Microsoft cloud customer. So that is why one of the reasons Microsoft is way up there. But we all remember there is one more service provider here, Google. Why is that Google? Such a big name is at the bottom. You can see it in the bottom right corner. You can see them. The reason is Google is a very, very good company, one of the great companies, I like it, but their strength is in their big data and analytics skills. When providing those skills as a service in cloud, they are good. But when I am starting a computer or when I'm starting a service for, let us say I want just 10 computers for doing some very simple WordPress blog, or I want to write a cooking blog article, I want provision 10 servers. Google Cloud is not very flexible and it is not very user friendly to use compared to Amazon. That is the reason you see they are visionaries, but they are not leaders there in that market. And you see a great group of guys on the bottom left corner, the big name, IBM, the nearest competitor, VMware, and Fujitsu. I'm not sure if anybody heard of Rackspace. They are also have a decent private cloud, but they don't have cutting edge vision of how to execute new features. They don't have a Docker capability as of now, which is comparable to Amazon. And you also have something called CenturyLink. Most of the technology for CenturyLink, to my opinion, comes from IBM only. So as you can see, Amazon is way ahead of the rest of the crowd. You can see a lot of distance between them, and this distance is not going away in the next near future. If you see the text on the right hand side, I have put the magic quadrant. The report says for the sixth consecutive year, Amazon is the leader, and I'm going to see that happen for the next couple of years at least. And maintaining leadership position in technology for 7 or 8 consecutive years is not a small thing, and Amazon is certainly capable of delivering that, in my opinion. So we talked about why Amazon is a cloud leader, and this is one of the reasons I repeat for choosing Amazon as a cloud service provider. Are there any other reasons? You can ask me, and let me see if I can present more evidence to say that Amazon is the cloud service provider that you need to choose and you need to pitch your bet on in your career. And so I'm just showing one more of Amazon's strength. Amazon has a written mission. I mean, every company has a mission, and Amazon Web Services, that is AWS, has a written mission, which on the right hand side I've listed it out. Their mission is to enable businesses to use web services and build scalable and sophisticated applications. What it means, the web services that they are talking about is the cloud that we are consuming today. And this mission, they have wrote it in almost in 2005 and 6 when they started AWS. So their idea was give the tools for developers, give the tools to businesses to build massive applications and to scale them to all across the world. And in the right hand side in the circle, you see some of the services they started with in way back in 2005. We will be covering quite a lot of the topics that you see there. And a company with this kind of commitment is where I want to put my money in. And are there any other advantages or benefits of choosing Amazon? I have listed some of them here. Amazon says, don't worry about your capital expenditure. Remember, I talked about CapEx in the first slide. Amazon says, don't put so much of money into your CapEx. Just make it as a variable expense. You pay when you want to pay. That is, when you move from 10 to 100 servers, you pay for the 100 servers, and when you shut it down, you don't worry about the infrastructure of provisioning it and making it running all the time, so that when the next peak demand happens, you have to have it ready. Don't worry about all those things, and don't worry about the scale of it from 100 to 1000 to million. You leave that to me, I will take care of the scale. That is what Amazon says, and you don't have to guess the capacity, whether it is going to be 100 tomorrow or 1000 tomorrow or 0 tomorrow. So worrying about it, I have given you the tools and you provision and make your business applications run. I will take care of the capacity. Likewise, Amazon gives you the speed and agility, that is 0 to 100 happens with a few mouse clicks and gets provisioned automatically without in a fault tolerant way. And also stop spending money on maintenance works. You don't have to maintain your data center anymore. No more cooling, no more cabling works, no more power cuts, all those things. Amazon takes care of those things. You just cut it short. And Amazon has something called a global presence. We call it regions, and Amazon regions are all across the planet except for 1 or 2, Antarctica and Africa. They have data centers in all the continents in the world map. So we talked about Amazon's leadership. We talked about why I have chosen Amazon as my horse for the cloud computing race. And I'm going to talk a little bit about what makes Amazon special from other cloud storage providers apart from what we saw now. Let us look into that little bit more detail. As I said, Amazon has an experience of building and managing AWS cloud since 2006, and the service breadth and depth I have mentioned is 40 plus services. That are very top level services, and each of them have multiple features available. We look into that. So a top level service itself, they have 40 plus, and they are at a rapid pace of innovation. Every quarter, not third quarter, every third month, let us say, they announce a new feature. If anybody follows Amazon, there is something called a reInvent conference, and this conference happens all over the world, here and there. And if you happen to join the webinar, at the end of the webinar, they will surprise the audience with a new feature that they are talking about. And as I said, they have a global footprint, and pricing is a very interesting concept they have. The more customers join, the more cost comes down. I mean, little a crude analogy is in the carpooling, think of one person and two-person sharing. Think of five people sharing the same car, and your cost comes down considerably. That is how the Amazon pricing philosophy is. More Amazon AWS customers, your price comes down, and there were 49 price reductions till recently. And they have a lot of partners working on creating new applications all the time. So Amazon has a great ecosystem to be part of, and you can also contribute to the Amazon ecosystem whenever possible by creating market products or other things. This is the slide which shows the global infrastructure. We might look into that more in detail when we are talking about in the classes. So this just gives a rough idea what is their presence. So as you can see, Antarctica, Greenland, Ireland, and African region is the only place they don't have a data center. So rest of all the places they have a data center, and each data center, each of those orange circles means more than 2 data centers in that region. So I should say multiple data centers in each of the major continents of traffic. And security, this is too much to absorb in the slide. Simply said, Amazon takes care of the bottom part, the line that you see in between the operating system, storage, database, networking, data centers, everything. Amazon takes care of the security of everything. So, and roughly the line is here. Why can't I draw a line? Okay, the line is here, and everything below this, AWS takes care, and everything above this, you take care. That is your applications, your access controls, your server security, your network security. So Amazon defines a very simple way. You leave everything below this to me. Your customer applications, your content is your responsibility because I am not creating it. Everything in AWS is my responsibility. That is how simple Amazon has made it. So you don't have to spend a lot of time. What is the permission should I give for a cron job? This is having a root level privileges. Should I tie down the cron job more? Or should I give access to my third party providers to my temp directory? Will they be able to read anything? Those kind of questions are completely off your mind now because Amazon takes care of the compute, storage, database security for you. And it is very easy to tie down even more also. So we talked about the special features of Amazon, and we talked about what security comfort they are giving for cloud service for cloud customers. Then is there any other special features for Amazon? Let us look at that now. Remember I talked about 40 features in the previous slide. That is a very high level features. One second. Let me clear my throat. So as on today, it is when I say today, I don't know how to put a date because Amazon keeps on adding new services. This slide was done about 1 or 2 months back, and at that point of time, Amazon had about 2,420 plus features in their cloud offering, and some of the bolded text that you see on the screen is some of the major services that they are offering, and the smaller text that you see there is the other services that you're offering. And we cover a good number of these services in our training. And when I say cover, we give you hands-on training and lab and also projects and some of those services. So we give you good level of comfortness when we are talking about enhancing or empowering you in AWS cloud services. So let us talk about some of those services in a very broad way. I'm not going to delve too much in detail. I'm not going to talk about the 2000, but I'm just going to show you a very high level of what we are going to cover in AWS. In AWS storage and content delivery, we are going to cover all of these things that you see here, from S3, Glacier, EBS, Storage Gateway, import, export, CloudFront. All of these services you will be very familiar in this training, at the end of this training, if you are going to join there. And this is what we cover in storage. This is the entire offering in storage. There is nothing else in storage they offer. And in terms of networking, we cover all the services that is available under networking. VPC, one of the, let us say that is the foundation of AWS. It is a spinal cord of AWS, I can say, if I can say that, because it ensures your security, it ensures that your data is protected, also your data, your services are scalable and isolated from other services. ELB, that is load balancer, Route 53 is your DNS routing and domain name hosting. Direct connect is how, you remember I talked about a hybrid data centers that is private and public are connected. That is where direct connect comes in. Think of direct connect sitting in between your private and public and connecting both the sides. We will teach you how it works and what are the options that you have in direct connect. And let us talk about a compute. These are the three main services Amazon offers in compute. EC2, auto scaling, that is how do you scale from 0 to 100, 100 to 10,000. That is where auto scaling comes in. Lambda is the completely opposite of it. Don't worry about your compute. Write your application code, give the application code to Lambda. Lambda will decide how much of computing capacity you need and it will give you the output. Lambda just runs on the time that you want to run, whether you want to run the code for, let us say, 10 seconds, 20 seconds, that is what you're going to define. And you are built for milliseconds. Think of it, guys. You are built for milliseconds. You're not going to build for hours or days or weeks. You're going to build for milliseconds. That is how Lambda is flexible, and AWS gives you that flexibility. In database, we cover our RDS extensively, and we also cover DynamoDB, Elasticcache, and Aurora to an extent that you understand what are these services and how to use or when to use them. In RDS, you will definitely get a Venkatesh, I will take your question. I have just another 5 to 10 slides. I will take your question of languages in the end. I have seen your question. I'll answer that in the end. So in databases, in RDS, as I was talking, you will get to know how to create an RDS database, how to take a backup of it, how to restore it, how to make it available in a fault-tolerant way, and also how to connect it with an EC2 or any other application and cache it with the CloudFront or anything like that. When it comes to DynamoDB, Elasticcache, and Redshift, you will be getting to know where to use them and when to use them. There is not much of a hands-on labs as such, but there is an extensive knowledge that will be shared on each of those services. Administration and security. Yes, I did say that administration is going away from most of the activities, but there is some amount of administration is still left out for you. For example, IAM, that is user ID management in cloud, which is completely different from what is done in on-premises. And you also have something like monitoring. Think of it as a Tivoli monitoring or HP OpenView, Nagios, whichever is familiar. CloudWatch is Amazon service for that. CloudTrail is nothing but an audit trail. Whatever you do, whatever anybody does, you can have a trail of that. And you have key management, trusted advisor, certification manager. You get hands-on access to all these services. You will be explained what are these services, how to use them, when to use them, and when not to use them as well. There are certain ways you should not use IAM. We will tell you how to not to use IAM. Application services. This is one group that I want to focus on. I have just listed 3 of the application services of Amazon provides, because these are the 3 services I can show you how it works and how you can use them and when to use them. There are other services way more complicated. It is a combination of these 3 and other services. It is extremely complicated and used by big web scale companies. And let us say that is advanced level of training. If anybody is interested, we can talk about that training later. But for a basic level, introduction of cloud computing, introduction of AWS, this 3 is more than enough. I have not seen a lot of companies use the advanced services. So we will be stopping our classes with this one. And quite often I get asked one more question: who is using cloud? Is there any banks using cloud? Data is being shared with tens and twenties of people. Are there any governments using cloud? This is just a brief sample of the logos that are using the cloud. And if I would like to bring your attention to the right hand side, public sector customers, you see at the big one, at the first one is NASA, and also you have some public departments using that, and also there are a couple of banks that are using it as well. And I have found out at least two banks. One is based out of Australia, and another one is based out of in Brazil. These two banks are also using AWS as their cloud service provider. So you can Google some other brands, some of the brands. You can find out where they are using it and what purpose. It might be simple, it might be complicated. So some of this sorry for that, I was just distracted a little bit. Some of the cloud customers are presented here, and you can Google them and find out more about them. That is what we are offering in cloud. So let's spend the next 10 to 15 minutes about why DevOps, what is wrong with the existing model once again, and why should I choose something in DevOps. That is what I would like to focus my attention on. This is one of the things that I would like to focus on. If anybody is an application developer or even an implementation team or a platform team, they would be familiar with what I'm going to say now. You will be asked to deploy something in the middle of the night. Usually, if it is an American client in India time, we will do it in daytime. If it is some other client, we will do it at mid of the night. And you will be given a stipulated time, 2 to 4. This is where you need to deploy the package on servers A, B, C. And don't do anything else. Just deploy this package and make sure the server is up and running. We are fine, and we call it a day and say deployments has been successful. But these kind of activities, if you notice, happens something like once in a month, or max is once or twice in a month. The deployments happen. What that means is, if you want to introduce a new feature in your application, let us just take a simple example. You have a login page and you want to integrate from existing user ID password to a Facebook login or a Gmail login. Let us say that is a new feature that you're adding. You need to wait a month. You need to wait at least 2 to 3 weeks to introduce a new feature into your application. So sometimes businesses cannot wait that longer. Sometimes your competitor will introduce that feature within a day or 2 days. So you are compelled to do it at the same speed. If you're not going to do that, all your customers are going to move from your servers to your competitor's servers. So the question of how many deployments per day becomes a big question now, compared to what is my lead time. How much lead time I have before I can do multiple deployments per day. So what I'm talking about here is, I have deployments, I have lead time. I need to balance both of these things, because a new feature, you cannot just think of it out from the sky and write it into code and test it and make it into a package and deploy it. So I need to do all these activities. This is the lead time I'm talking about. A new feature conceptualized and functionally written as a feature and tested, and then you need to build that code and then make it, when I say build, make it into a package that is deployable, and then you're finally deploying. So I need to reduce my lead time as much as possible, and I also need to increase my deployments as much as possible. So in a conventional way, we know that I just talked about it, we deploy once or twice in a month. So in DevOps, what we are talking about is multiple deployments during the day. During the day, I repeat it. We are not talking about midnight deployments. We are not talking about peak, lean period to avoid the peak customers. For example, Intuit is an accounting company based out of the United States, and like every other country, you need to have a tax filing at a certain period of the time, a certain period of the year. And Intuit was able to deploy new features, new changes to their code during the peak tax filing season. And the reason they do it and the way they do it is because they have adopted DevOps philosophies. What I mean by that? So the same question that I'm asking is, what is your lead time for changes? How long does it go from a code committed to code successfully running in your production? These are the questions keeps on coming in IT managers and functional managers, product owners. So how can I reduce the lead? How can I reduce my lead time, and how can I increase my deployments into production? When you balance these things, you get DevOps philosophy. For example, I'm showing you a brief slide of what Amazon does. If you can see at the top, or if I can draw a line, possibly in another different color, just a second, you see that Amazon is deploying almost 11.6 seconds. Every 11.6 seconds, they have a deployment happening into their production host. And they are deploying to almost 30,000 servers at any given point of time. That is massive in my opinion. 11.6 seconds, by the time I finish the sentence, Amazon has deployed something. By the time you think about what I've said, Amazon has made one more deployment. That is how fast they are doing the deployments. So let us look at that a little bit more. I mean, it is staggering in my opinion, at least. I'm not sure how many of you are familiar with the DevOps or already doing DevOps. Doing something new, releasing a new feature in 11.6 seconds is amazing. So this is what very, very high level pictographic representation of DevOps. Left hand side of the line is what a conventional or quite often enterprises do this. There's a developer who writes the code and then just blindly throws the code to the operations guy saying this is the package that you need to deploy, and without telling him whether the package needs to be highly available or what is the network requirements after this package goes online, what is the backup requirements, what is the monitoring requirements. Some of those information gets transformed to the operations guys. Sometimes it doesn't get passed on to the operations guys. So that both of the guys are grumpy, as you can see. They are not happy with what they are doing. When you come to DevOps, there is a close integration or close communication between the development team and also the operations team. What do I mean by that is the next slide gives you a very nice way of putting that in words. There's an operations team who thinks like devs and also a developer who thinks like ops. That doesn't mean that developer will start writing network code or start doing cabling work. You just need to understand a little bit of operations, and at the same time operations guy doesn't have to think like a developer, doesn't have to write a code. You just need to know what the package will contain. Let us think of a common medium between both these guys. So that is what a DevOps is. Both of them will be communicating with each other, and they know what to deploy, where to deploy, and what are the requirements in the package, and like that they can deploy more packages. So just like that, by introducing a little bit of flexibility in both the teams, we are able to increase the deployments into the production to more bigger scale than we have seen. So I have put in a big text at the bottom. If you have the patience to read it, go ahead and read it. If not, I'm just going to summarize it for you. I have listed some of the most common elements, DevOps elements that is used in the market. In the top layer, I have put Git and GitLab, that is your version control repository. Your companies might be using Subversion, Tortoise, or IBM Rational, or the Oracle product is also there, ClearCase. So many tools are there. I'm putting Git and that I'm putting all the open source options here, Git and GitLab. Then it comes your Jenkins and Jira. Jenkins is a more an orchestration tool, which think of it as a glue which binds all the other tools, Git, Puppet, Chef, Maven, all those things, and Docker. So Jira is your ticketing tool. If anything goes wrong in your code and when the testing happens, Jenkins finds bug, it is getting the ticket is raised, or a defect is getting raised, or the blame is getting raised in Jira. That is where Jira comes in. In the third layer, I have this configuration management layer. What do I mean by that is, let us say you have provisioned your application servers and everything. Now you need to deploy the application on top of those servers. You need to configure your heap size. You need to configure the port numbers and all those things. You have plenty of tools available in the market. I've just listed the three common tools. Chef and Ansible is what we will be focusing on in our training. It will be mostly Chef or Ansible, either one of them. And we are finalizing the course material on Chef and little bit on Ansible. And in the last layer, it is a mix of a few things. You can leave Python. It should not be exactly there, but I'll touch upon the topic of Python, why it is there. Docker, mostly DevOps use containerized environments. We are not talking about full-fledged servers all the time running with the different versions of applications. We deploy it in containers. That is where Docker comes in. And Maven, remember I talked about building the code. So Maven comes in to build the code into a package which can be deployed into a container. It can be a Java code, it can be a Python code, it can be any language code. Maven makes it into a package which is easier. Like for example, you have 10 different files, 20 different folders, and another 5 configuration files, and you need to configure it in the same directory structure to a target environment. How do you pass on this information to an operations guy? You need to write a detailed set of instructions saying directory A goes here, directory B goes here, this information goes here. Instead, think of it, you can make it as a single zip file or some kind of structure that Maven will provide for you, and you can deploy it into a container and the same directory structure is replicated. That is where Maven comes in. Python is very, very helpful for writing a scripting language and also interacting with AWS Boto. And if you are familiar with the Python, I would say Chef is very, very easy to pick up and start running with it. That is the reason I have put Python, and we spend a good amount of time in Python in this DevOps training. So what we cover in DevOps, Git, Jenkins, Chef, Docker, and to a certain extent, you will be familiar with Python as well. That is what we cover in DevOps in our training. So finally, I can go to the next slide. So then come back to that one. I would like to take some questions. That is what I've done talking. And to start off, before any other questions, Mr. Venkatesh had asked one question: is it required any languages like Linux, Unix, Java? Well, Venkatesh, when I'm talking about AWS, you don't need to have any programming experience at all. It is not mandatory at all. But I would not be surprised to find a person who is having a little bit of Linux knowledge to pick it very fast than compared to a person who is not having Linux knowledge. Having said that, if you follow the classes, if you attend all the classes and do some of the classroom assignments and homework assignments, you will not find it any difficult than a person with Linux knowledge. You will be on par with a person with a Linux knowledge. And compared to Java, I mean, you don't need that when we are talking about AWS. The question changes a little bit when we are talking about DevOps. As the name says, it is developer and operations. It is a mix of both. So I am going to say coding knowledge or a little bit of programming knowledge definitely helps there. Definitely helps there. But again, you will have to put in more hard work and even more greater amount of homework study and spending more time otherwise to get yourself to speed if you don't have the programming experience or coding experience. So in other words, AWS, you don't have to have any worries. DevOps, you need to start learning a little bit of scripting and programming. And there's another question from Mana here, and the question is, does DevOps require to learn Linux and programming and scripting knowledge? I would say scripting knowledge or Linux experience would definitely help, because in case your Docker containers or the Maven's, the Jenkins is malfunctioning or throwing up some logs, it is easier to troubleshoot when you have some experience. So little bit of experience helps, and Python coding is definitely necessary, or if you want to interact, or Ruby coding is definitely necessary to at least to a basic level if you want to use Chef. If you don't want to use Chef, then you can leave about programming there also, because Ansible is another option, as I said, we are exploring, which doesn't need any programming, any coding or any scripting skills for doing your configuration management. Let me repeat that. For Ansible, you don't need any coding. So I'm talking to Ravi and one more our trainer, Mr. Krishna is there, who is fairly experienced with Ansible, and we are trying to see whether we can induct Ansible into our training. As of now, we are talking about Chef. since more and more students are asking about non-programming or non-coding configuration management tool, we are looking at Ansible as an option. So to simply answer your question, scripting helps, programming knowledge helps, but not mandatory if you're ready to put the hard work. Thank you. So, is there any other question from anybody else? I see about 18 people in the room, ignoring about 4 or 5 organizers in the room, and some people who have joined multiple times. I'm seeing at least 10 people. I would like to have some more questions, guys. Shiva, there's one more question from Shiva, Mr. Shiva. How it would be a lab practice on these tools? Very good question, Shiva, very good question. AWS gives you something called free tier access. That is, we will help you to register for the free tier access. What it means is you can have access to real-time production level tools in the lab classes. I can help you to test some of those topics that I'm talking about in the class without spending a single rupee of your money. And I will tell you when you will incur cost, when you will not incur cost. So in other words, you will have real-time production level tools for your lab practice. Does that help? Is there any jobs only with AWS? Yes, Prasad. Yes, Mr. Prasad. Definitely. There are, you can Google it as well. If you're in India, you can Google it in Naukri. If you're in US, you can Google this in Indeed. You search for AWS consultants, AWS engineers, or instead of remove AWS, you change the word into cloud consultants or cloud engineers. And also there is a role called cloud administrators also. Their job basically will be to ensure EC2 instances are set up, ensure that storage is set up, and ensure that you are able to run your EC2 instances without errors, and you are able to run your databases without any problems, ensure high availability is there, create any users or problems logging into users. A typical administrative work. And also when I say consultant, you get an opportunity to work in RFPs from customers. If it is a smaller RFP for setting up a 5 to 10 server environment, I keep referring to the word environment and resources because in AWS, everything in a VPC works as a group, like network, storage, and servers. Together, we'll call them as a resource or an environment. And if a customer comes for a smaller environment as an RFP, your company might ask you to provision it yourself instead of going through a solution architect, or there will be an infrastructure or cloud architect usually. If it is very small, you will get to hands-on RFPs as well. The reason I say RFPs is that is the stepping stone to becoming a cloud architect or a solutions architect, because the RFPs will come in something like, I want to have a service up and running with high availability and also networks. So from that single line of statement, you need to create what type of storage they need, what type of servers they need, whether that needs to be in US region or whether that needs to be in Indian region. And that is a very good question. I kept on referring to the word RFP. What it means is a request for a proposal. In other words, the client has a very business requirement. As I told you, the request for a proposal is a business requirement. From that business requirement, you need to convert it into an operational requirement, that is servers, storage, and networks. And there will be a real-time or a lab, instead of saying real-time, real scenario lab classes, project scenario lab classes at the end of the training. Yeah, good, Bharat, I was just touching upon the same topic. There are some real-time project experiences I can bring in from my experience, that is enterprise experience. We have already demoed it 2 to 3 real-time projects in the previous batches, and I can show you real-time demos of 2 or 3 scenarios, and I can also provide you other scenarios that you can work on your own leisure time. And of course, all of them will have, what we are looking at is, we are trying to look at real-time scenarios with the instructions, whichever we are doing as a homework, and also trying to give an auto script, which you can run and set up and try to see. You don't have to understand the script, but if you run the script, it will set up the environment for you. And if you run the script again with the cleanup options, it will clean all the resources for you. So in short, Bharat, yes, we do have real-time projects, and we will show them, show some of them to you, and we will ask you to do some of them of your own. So I just moved on to another slide. We have spent quite a little bit of time. I'm not sure what we are time running out. We are about close to 8:30 now in India time. I think that is good. If you have any other questions, I can continue answering them. Meanwhile, I have shared the uh, contact number of whom you need to contact for getting more information on the training schedules and also the fees and what material we cover, what we not. All those kind of questions can be covered offline as well through that number. And if I don't think so, it would be too much to ask all of you guys to drop in your email and the phone numbers in the chat window if you're interested, so that we also have a means of communicating you or persuading you to consider our course.
Yeah. Thank you, Naveen. Thanks for this class. And guys, yeah, if you are interested, what you can do, you can just send your email ID and phone number in the chat window, or else you can ping me in this number. I will be in WhatsApp, and we will tell you the schedules, what happening on these classes. And we are running with AWS plus DevOps and AWS independently and DevOps independently. It's up to you to choose which course do you want to join. And that's all from our end. If you guys have any questions, I'm going to unmute up you. You can ask directly instead of typing. Okay.